right, so this is our second lesson of the unit. Today I want to talk about how we can solve math problems with paper folding. Okay, so over the next 3 weeks, we're gonna 3 sessions at least. We're gonna talk about different mathematical tools that different cultures have come up with to deal with math problems and solve math problems. And today we're going to talk about origami, which was developed by the Japanese. So origami is Japanese, the name. Origami means to fold paper. Okay, so the Chinese invented paper around 105 CE, which is about 2,900 years ago, and Japanese monks brought it to Japan about 400 years later. At the time, it was a luxury item, so any paper folding that they did was mostly for religious ceremonies. By the 1600s to the 1800s, paper folding was more common, and it was something people did for fun because paper could be mass produced and it was affordable. Now, written instructions for origami first appeared in 1797 in the Sembaruzu Orikata, which meant 1,000 crane folding. Orikata meaning paper folding. Okay. By the 1800s, they changed the name. They began to call it origami. So that's the word we use today. And modern origami has models that are created by designers and can often be really complex looking. So, like what we see in the GIF right here, that's a basic origami technique. But more complicated techniques are like ones on the left, like the octopus and the horse and these weird art sculptures. Okay, those are all made by modern origami. And they take more complex like math and design tools to be able to make something like this. Where these ones on the right are some basic traditional origami images or pictures and can be made fairly simply. So basic origami uses the following folds, these basic folds: the inside reverse fold, the outside reverse fold, which are down here, the rabbit ear fold, the squash fold, which is right here, the pleat, which is right here, the crimp, the petal fold and the petal fold variant, the swivel fold, which is right here, and the open sink fold, which is right here. Okay. So, origami can be used in math by basically origami to start off with uses geometric shapes, okay? And they can be proof to math that's difficult to figure out by numbers alone. There are also techniques like modular origami, where you use repeating units of origami to make more complex geometric forms, okay? So that's kind of like this one right here that you see in the picture. Origami, so basically when you're folding origami, you're making shapes, right? You're making shapes like triangles and squares and trapezoids and all kinds of things like that. So you're learning about shapes. You're also learning about angles. Um, Crease patterns are a way of looking at origami by unfolding the paper and looking at the pattern folds you made in that paper. It's like a flat model of the origami that you did. So here on the right is an example of a more modern crease pattern, and it makes this deer that you, or the moose, I think it is, like that you see right here in this picture. So this becomes that. Crease patterns have led to theorems about geometry, like Morikawa's theorem and Kawasaki's theorem. Kawasaki's theorem states that the number of mountain folds, so like, it looks like a mountain, like a, thing, in a flat folded vertex figure differs from the number of valley folds, or like upside down, it's shaped like a V, folds by exactly 2 folds. Okay, so it's like unfolded, this orange piece of paper would look like that crease pattern. And basically the number of mountain folds differs from the number of valley folds by 2 folds. So there's a difference of 2. Okay. Um, Origami can also solve some classic construction problems of geometry that can't be solved using a compass or a ruler. So origami can be used to solve engineering problems. The Majura Matfold, which you can see in this GIF in the top right, allows us to deploy large solar panel arrays for space satellites. And I'm going to show you a little video of that right here. Yeah. So that basically gives you an idea of how like origami, like they basically used origami to figure out the design and then made it out of like metal and glass and solar panels. So it's kind of really cool how origami can teach people how to make something like that, that can actually be practically used in real life. The napkin folding problem proves that a square or a rectangle can be folded so the perimeter of the flat figure is larger than the original square, which is kind of crazy. Sorry. Next slide. Okay. Origami can also be used to solve other engineering problems, like curved origami allows paper to form round surfaces that are not flat. So it takes flat paper and it turns it into something curved. And wet folding origami allows us to do a larger range of shapes and different kinds of things. So we can use that to solve some engineering problems, like to do things that we need. Um, so, actually, I think this is it. That's the last slide. So, you're going to be doing an exercise where you actually get to fold some origami. You can use any kind of sheet of paper that you have at home and fold, an origami figure, and then you're going to take a quick video of it. So, go ahead and check out the next assignment, and I will see you next week. Thanks, guys. Bye.